So we are going to be finishing up 13.3, starting a little bit of 13.4 today. This is the unit circle. This is the one that is completed out. Again, this is the thing that you need to memorize. I'm going to be referring back to this, so it would be best if you just kept on this page and at least like have your finger mark there, or maybe bend the page down, and then get to some opening room so you can see what I'm doing. Maybe write it down, or if you just want to watch. In fact, I'm not gonna mind that too much today, because at least you understand the concept. It'll help us out later on. So for today, all right, so for today, you guys have seen this thing, which is an X and Y chart, correct? And on this thing, you've been able to put like dollars, like this is allowed to represent, the X has been able to represent years and time, right? And you guys have been able to use this as dollars, correct? And you've seen graphs, and you're okay with that, yes? It doesn't bother anyone, right? What does time bring? It's a measurement, right? It's a measurement, right? What is dollars? It's really a measurement. What are radians? A measurement of what? It's a measurement of angles. Remember, that's what we talked about. Degrees and radians measure the same thing. They're just a different unit. So, you were able to put time and money on an X and Y chart, and there was no bother there. Didn't bother you at all, right? What else do you think you're going to be able to put on this X and Y chart then? Radians, because it's just a measurement. So we can do that also. So today what we're going to talk about is coming up with the graph of sine of theta. There's one confusing part that I want to make sure that we get through, so hang with me on this. When we do a graph, what do we normally have? X and a Y, another way of saying that. Another way? That's what I'm looking for. We have an input, we get an output. That's where our X and our Y's come from. Does everybody understand it? So, X and Y. An input and an output. What did I tell you sine of theta equaled yesterday? Sine of theta equaled Y. What did cosine of theta equal? X. What did tangent of theta equal? Very good. That's going to help you out again when you get the trig. You use that more. You're going to use that a lot. So sine of theta equals Y. Wait. I got an input and I got an output. When I write X, I really just mean my input. When I write Y, it just really means my output. Are you with me? Okay. Can I put 1, 0 into this? Can I put, if I put 1 in here, do I get 0 out? What does theta stand for? An unknown what? An unknown angle. So when I go back to here, is this my angle? The 1 is 1 my angle, and is 0 my output? No. What is my angle when I am on this? 0 is my angle. You with me? That is my input. That's my theta. Sine of 0, because 0 radians. You with me? I'm measuring in radians right now. The sine of 0 radians is the Y value, which is what? 0. This is awful. 0, 0 is my first one. Hang with me, it should make sense here very soon. What's another input that I could use? Well, let's go back to that unit. Go back on your unit circle. What's another input that I could do? Do the middle one. Do one middle and halfway in between there. Okay? But I'm not talking about 45. How do I know I'm not talking about 45 degrees? What is this unit of measure that I said I want to be doing down here? I want it in radians. So what would be my input for 45 degrees, really? So pi over 4 is my input, because it's my theta. It's my angle. Sine of pi over 4 equals what? What is the y value of that ordered pair on the unit circle? Square root of 2 over 2. If you take, just let it sink in a little bit. If you take square root of 2 and divide it by 2, you get about 0.707. So on here, can I say this is 1? And then this is a fourth, a half, 3/4, yes? What is this over here going to be then? What? These can have different, X can have a different measurement than Y. What's my first input? So what do I want to count by? Pi over 4. My input is pi over 4. Pi over 2. Because I went up another fourth. You're making it way too difficult than you need to. Relax. Relax. Pi over 2. Look, Sage. If you go like this, look. I go up a fourth. I go up a fourth. I'm still going up the same measurement. So I'm still going up by increments of a fourth, but it's a pi over 4. A 2 pi over 4, but it reduces to pi over 2. So I'm going up from here to here to here to here, and those are my inputs.
So for your values of the x-axis, y, I don't know, just keep going.
I'm just making a graph.
So like,
just picking inputs. I don't have to have every value on there. I just want to see what the graph looks like. It doesn't have to be. Remember when I did quadratics, did I pick every x and make every y? Or did I pick key characteristic ones so that I could just get the shape of this, what it looks like, and I could predict where the other ones would fall? I could just make this shape with my eyes. So, same thing I'm going to do here. If I take, and my input is pi over 2, bless you, it's going to be like pi over 2. If that's my input, which is theta, pi over 2, what's my output? The y value, which is 1. So I go up here, and I say, okay, pi over 2, and I go up to, well, let me graph this one. This one would be about right here, that 0.707. Pi over 2 goes to 1. What would be my next value that I'm going to check the input of? 3 pi over 4. And what's the input of that, or output? Square root of 2 over 2, because it's still the y value from that ordered pair. You guys understand what I just did? 3 pi over 4. And it goes to right here. I'm going to start squishing this a little bit just because I need to go further over. Just for sake of being able to fit it on the screen. Does that make sense? So what would be my next value that I'm going to go to right here? Pi. And what is the output? 0. How do you know? What is the sine of theta? Always equal to the y value. What is the y value? So if I go back, because I feel like I have a lot of question faces, if I go to pi, it's the y value. The y value is 0 right there. You following me? Yes? Finish the rest of that graph, going all the way to 2 pi. Finish the rest of that graph going to 2 pi. I'll help you out. The next one I'm going to do is, that's my next input, my next input, my next input, and then 2 pi would be my last input. So I gave you all the inputs. I want you to think of the outputs. Next, I want to, like, my kids in. So let's finish this up. So what you should have done, if you were making these inputs and outputs, you should have kept going on. What's my next one over here? 5 pi over 4, then 3 pi over 2, then 7 pi over 4, then 2 pi. And this should go 1, 2, 3, 4. This video's going to sound awesome in it. I'm so excited. Here, then this should go to 1, then this should go back to here, then this should go back to 0, and eventually, like we said, it's going to make a graph like that.
So it starts at 0.
This one starts at 0, 0.
We had that.
You guys with me on this? Now, am I allowed to have negative degrees?
In this one. We'll wait, not for x.
Am I allowed to have, can I have negative pi over 4? What did we say that does? What if I went negative pi over 4? That would get me to this location, right? Which is a what? Negative 2 square root of 2 over 2? Well, let's look and see if that makes sense for my graph. Does it make sense for my graph? Where's this thing supposed to be looking like it's going down to? Down to negative, doesn't it? So it makes sense that it works out. So you can, this graph keeps going this way and it keeps going that way. And that's why we talked about when you have a negative degrees, you're actually going this way on the units. You're going that way on the unit circle. Does that make sense? How are we doing? Chills. Multiplying. That's what math does to some people. What?
So, just to be clear, when you're going from input to x, you always look at the radians.
Because when I'm doing this, what does theta stand for? Angle. Okay? So that's why you're looking for radians, because radians are a way of measuring. Now, could you make the sine graph in degrees? Yeah. Instead of this funky number here, you would have 45. And then you'd have 90. And then you'd have, this is just, remember how I said you can write a graph and you guys are perfectly okay with this being years, and this being money, or dollars? Well, couldn't I do this in hours?
Oh.
And couldn't I do this in pennies?
So it's just comparing two different measurements.
It's just that this is a way of measuring a degree, or an angle.
Okay.
And this is one of the ways that you can measure it. And so I did it in radians. So this is in radians, okay? The other way I could do it is if it was in degrees, and then this would be 45, 90, and then keep going on. Yes?
Yes. And then the y, you just plug in the y coordinate.
You look at the y coordinate from your unit circle. That's why the unit circle is so important. And if you plug that in, if you actually hit on your calculator, the sine of, let's say you did the sine of 90, it's going to pop out a 1 when you put that in the calculator. If you hit sine of 90, or 90 sine, 1 is going to show up on your calculator. The unit circle shows you those inputs and outputs quicker. And like I said, if we wanted to graph cosine, we would do the same exact thing. If we wanted to graph cosine of theta, we would do the same thing, except this time we'd be looking only at our x. And so you would still be, your input would be your radians, and your output would just be the x coordinate on your unit circle. So actually, Where does cosine start? It would be 0 radians. What would be my output? 1. So actually, cosine starts up here. And it would still be a wave like that, but it looks like that. Whereas sine does the y and starts here and goes like this. You get what I'm showing you? Okay? The reason is sine of theta uses the y value, whereas cosine of that same angle uses the x value. And tangent uses the y over the x.
So how does this relate to like the actual world? And like Amplitude?
We're not getting there.
How are we like,
Let's just... Okay. I need it all. Alright, so what we're going to talk about for the next section is you can have sine of theta plus 2. But we've already done some of this. We've done all this. I told you it's going to be the same ever since the beginning. What happens when you do that? What's it going to do? Just move it up 2. Okay? When you have this, what's it going to do? Okay? It's going to, and we'll talk more about it, it's going to stretch. And this is the vertical stretch. So think about what would happen if I pulled this up and I pulled this down. It's going to go like that. You with me? Now the other thing we need to talk about, 2 things, is the distance between here and this midline, which is where it starts to, you know, kind of shift itself to the other side. From here to here is the amplitude. Well, how do I get my amplitude? Is I'm going to take my maximum value, because that's an unknown value I normally get. We'll talk about that. We'll talk about how to find the minimum. And the amplitude, how can I find the amplitude if I know my max and my min? Well, isn't that distance from here to here? What if I know the distance between my... I need to find the difference between them, actually. Because that's going to be my distance. So I find the distance from the top to bottom, but then I have to do what to it? Amplitude is only this part divided by 2. Does that kind of make sense? Another thing we need to talk about is called a period. Okay? A period is how long it takes to repeat itself. So like, do you see how right here I haven't repeated, no repeat, and then I'm about to start repeating? So this time it takes to get from here to where it gets to here is called my period. So if I was on my sine function, you guys remember the sine function? I'm just going to draw it real quick. We just graphed it. It took from 0 to 2 pi to get to where it repeated itself. So my time period would be 2 pi is my period, because that's how often it takes for that sound wave or whatever to repeat itself. Does that make sense? Last thing I need to talk about. I got time, give me time. If I wanted pi over 4, and I wanted the same exact, I think this is important. I want this to be at the same location. Can I just add 2 pi to it?
what do you mean in the same location?
So if I go like this, I go back here. I want to be at this location right here. Well, I go, so I start here, and I go to here. So it took me, essentially, it's pi over 4, right? Or, I did that. So, how do I write that out? 1 complete circle plus whatever I have. Or I could even do 2 complete circles. Now I've gone 2 rotations, but I stopped at the same location. It's like when you get on the Ferris wheel and they start loading you and they stop you right here at this location, and then you get off and they stop you again at that location. Well, you've done like 5 rotations, but then you still end up at the same spot. Do you get what I'm talking about? That's why that sound wave, that's why this sound wave keeps going like this. because this is the first rotation around it. Here's the second rotation, but look, when I did this one, I end up at the same location that I was here. And we'll talk about those periods. I need to get talking about those next time. Good?